Corporate finance practice problem using Excel. Capital budgeting with reinvestment rate assumption. Get ready, it's time to take your chance with corporate finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet and would like to follow along, note that we're in the practice tab as opposed to the example tab. The example tab in essence being an answer key. Information on the left-hand side, populating that information, working through the problem on the blue area in the right-hand side. We have a situation where we're going to put that initial down payment down once again, as we've seen in prior presentations. It might be for equipment, it might be for an investment, it might be for a project, it might be for inventory. Point is, we're putting that down, cost of capital 10%, in order to receive a return in the future. This is our plan, at least, or we're thinking about doing this, that we're going to get. In this case, we're estimating 5 years out in a cash flow in this format: 128,000, 130,000, 90,000, 16,000, and 28,000 in the future. The primary tools to analyze this type of project, whether to accept it or not, are net present value calculations and the internal rate of return calculations, both of which take into consideration the time value of money and are related in some way. So we've looked at those in prior presentations. As we've seen that, you might be thinking, well, if I get the cash back sooner, and I assume I'm going to get a rate of return on that, wouldn't I want to think about this full project in terms of the return I'm going to get on the cash I'd get sooner as well? So we might take that into consideration. So for example, if I wanted to look at the inflows and assume that we're going to reinvest the inflows, getting the money sooner than reinvesting the inflows, what would be the net effect of the cash flows if we were able to do that? Meaning, again, assuming that we get this money back and we reinvest it. Now, there's two ways we can make that assumption. One, we could say, well, if I get the money back and I reinvest it basically at the cost of capital, which is typically our required rate of return or our hurdle rate generally. Or we might say that I'm going to get the money back and try to reinvest it at the same rate I'm basically getting on this project, which would be the internal rate of return. We can use the internal rate of return. Of those two methods, the cost of capital is probably the better one, the safer one to use, considering the fact that the reason we picked this project is because it resulted in the highest rate of return, the highest internal rate of return we could find, for given the risk and whatnot, any other factors we're taking into consideration. So if we use the internal rate of return, as we get the money back, we might be overstating the return we could get elsewhere in other projects, because this is a long-term project with higher risk. Probably that would mean that the internal rate of return would be higher than maybe we could get elsewhere. So it would probably be safer to use the cost of capital, but you might try either one and do some scenarios. So let's take a look at our inflow with that assumption. So we're going to say, let's say we have the inflows. I'm only looking at the inflows 1, 2, 3, 4, and 5 on the years. Going to center this, go into the home tab, font or alignment, and center. Then we're going to have the total on down below, total. That's not a T, that's a Y. Total. And then let's put our flows here. The 128, I'm just going to copy that down using the autofill, putting my cursor on the autofill handle and dragging that handle on down. Gonna underline it here and then sum it up. Equals sum, SUM, shift 9, and summing it up. Now we're going to do a future value calculation, assuming that we get a rate of return as the money comes in. So this first one, we got 128,000. I'm going to assume we're going to reinvest it. My voice totally cracked right there, but I'm going to assume we're going to reinvest it at the 10% for the remainder of the time period, which is this 5 years. So we're putting the 300,000 down. We think we're going to get 128 back in year one, and we're going to reinvest it. Probably not getting the same internal rate of return as this project, maybe, but hopefully getting the cost of capital by reinvesting it as soon as we get the money back. And that would mean we'd get 4 years of investment after we get the money back for this particular project. So let's do the future value calculation here. This is how I would do the calculation. I'm going to say this equals, or let's say negative of, the future value, shift 9. We're talking future value now, not present value, future value, future value. We're going to pick up the rate, which is going to be that 10%. I will not make it an absolute value yet, but I will do that shortly. So we'll see that in a second, comma. Number of periods. Now, the number of periods is going to be 4 because as of this point in time, when we get the money back, there's 4 periods out. So how can we work this table so I can copy this down easily? One way you could do it is you could say, I'm going to take this 5th year and then make that an absolute reference. I won't copy it down now, but you would make that an absolute reference minus the 1st year. That would be 4 years, right? 5 minus 1 would be 4. And when I copy it down, this 5 will remain the same, and then the 1 will move down, meaning the next one will be 3 years and then 2 years and so on. So in other words, you would absolute reference this one too, which I won't copy it down yet, but you'd want to absolute the rate because it's outside the table. And then I would set this up this way as well, and then comma, comma. And the present value will be this item. So I'll do it a few more times because I kind of stumbled around with that explanation. So let's see if I can do it better this time. We're going to say future value, negative future value, shift 9, rate. Now this is one we would absolute reference, F4, $ before the B and 4, comma. Then the number of periods. We're in year 2, so if I got 130,000 back at the end of year 2 and invested it for the rest of the time period, for the rest of the 5 years, that would be 1, 2, 3 years. But I want to be able to copy the formula down. How can I do that? Well, I can take the 5th year, absolute reference, so I copy it down. That will stay the same, minus year 2, and then 5 minus 2 is 3, I believe. I'm pretty sure. And so that's what we want. And then when we copy it down, it should copy it down, but I won't do that yet. Comma, comma. And then the present value is that 130,000 and enter. Okay, let's do it again. Negative future value, shift 9, rate 10%. We would absolute reference F4 on the keyboard, $ before the B, $ before the 4, comma, number of periods. We'd say 5 down here, absolute reference F4 minus the 3 up top, therefore the 5 would stay the same, 3 would then move down, comma, comma, chameleon, and then 90,000, and enter. Do it again, future value, shift 9, rate, the rate is going to be the 10%, F4 absolute value, comma, number of periods would then be 5, absolute value, F4 on the keyboard, minus the 4 here, comma, comma, 16,000, enter. One more time, future value, shift 9, rate, absolutize with the F4, comma, number of periods would then be, I'd say 5, absolute reference, minus 5, right, because it's the same thing there, and then comma, comma, future value or present value, and enter. So there we have it. Let's do it again. This time just copying it down just to show that this kind of thing that I did works, copying it down. It totally works. Watch. Watch. This is how you want to do it because it totally works. So this will be negative future value, shift 9, rate is going to be this 10%, F4, comma, number of periods. We're going to be picking up the 5 down here, absolute reference, F4 on the keyboard, minus the 1. So the 1 will move down, the 5 will not, and then comma, comma, and the present value 128 and enter. And then we can just put our cursor on there and absolute and then drag it down, fill handle. And it does exactly what you would expect and moves down the way we want it to. Super, super good. Font group underline, let's sum it up, equals sum. And there we have it. So now we got the 514,935. Now, again, this would then be the future value. We're looking basically now at the future value, assuming that as we get the money, we're going to reinvest it. We're going to reinvest it at the cost of the capital, assuming the investments are there that we can do at get a rate of return at the 10%. Now, you might be asked, what if you were to reinvest it at the same rate that you have the cash flows in? So let's check that out, because then we can actually calculate the internal rate of return, see what we're getting in terms of a return here, take that money as we get it back, hopefully invest it somewhere else and get the same rate of return. Now, that's a bold assumption, thinking that we can get the same rate of return as this long-term project. That's a more aggressive stance, not as conservative a stance, but, and you might be asked that on a book problem, because then you have to calculate the internal rate of return too. So let's go ahead and do that. So I'm going to say, let's calculate the internal rate of return and then do the same thing with that rate. So we'll sum these up and then say alignment. This will be the total. And then I'm going to say the internal rate of return, I'm going to say negative for the outflow is the 30,000. And then the inflows are going to be that 128. Copying that down with the autofill, putting my cursor on the autofill handle, dragging it down, underline under the last one, font group underline, and then we'll sum it up. Equals SUM. SUM. It up. So there it is. And then we'll just use the internal rate of return function to give us that rate. So we'll do that kind of the easy way here. This equals the IRR, the as I call it. No one else does, though. So if you say that to anyone else, they'll probably think you're a chicken saying something, saying at them. Anyway, IRR, enter, that's going to be 13.45. So now, let's assume that as we get the money back, we're able to invest it at the higher rate, the 13.45%, and see where our future money flow would be that way. So let's do the same thing, 1, 2, and then copy that down, and then go to the alignment and center, and then we're going to say this is the total, and the inflows are going to be equal to the 128, and then I'm going to do this with the keyboard this time, Control-C, down arrow, holding down Shift, down, 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 Control-V, paste in it, and now let's do our future value calculations. Negative, future value, FV, Shift 9, rate is now that 13.45 because we're thinking we can get that same return as we get the money back, because we know we're good at finding places to put our money to get a return. And then the number of periods we're going to say is going to be, and by the way, of course, you would do the same thing. This would be F4, comma, and then the number of periods would be the fifth one, F4, so that stays the same when I copy it down, minus the first period, comma, comma, future present value 128. Let's do it again because I kind of bobbled that one up. So let's do it. See if I do better this time. Future value, Shift 9, rate is now going to be that 13%. We're going to F4, which means absolute reference it, so that if I copied it down, it would stay the same, comma, number of periods. I'm going to take the fifth period, make that an absolute F4 minus the period we're on, period 2, comma, comma, because it's not an annuity, but present value of 1. There's the 130,000. Let's do it again. I'm getting good at this. We're getting good. Flowing now. In the flow. So this is the rate, and then we're going to say F4, $, absolute reference. Number of periods is 5. Absolute reference, F4, $, before the D, and 14 minus the 1. And then comma and comma, because it's not an annuity, but future value of 1, and then the 90,000. One more time, and then we'll copy it down. Let's do that one more time. Hold on a sec. There's a problem here. There is a problem. This D10 is not right. That's not right. It should be this 3 right there. Okay, let's try that again. Let's do it one more time, because I messed that up. Future value, Shift 9, rate. Going to get it right the whole time this time. This is going to be F4 absolute reference on that one. So we're going to select F4 on it, and then comma, number of periods is 5. We're going to pick up the 5 down below, absolute reference F4, and then minus the 4, comma, comma, future value or present value, the 16. One more time, negative, future value, Shift 9, rate 13.45, F4 on the keyboard, comma, number of periods would be that cell, F4 minus the same cell this time, comma, comma, future value 28, enter. Okay, I think I did at least one of those correctly, so I shouldn't confuse. Anyway, I'm going to delete these and copy it down this time. Let's do the first one more time and copy it down just to prove that that works. This is going to be negative future value, Shift 9, rate 13.45, F4 absolutized, comma, the number of periods, I'm going to pick up 5, F4 absolutized minus the one we're on, period 1, leaving 4 periods, comma, comma, then the present value 128. There it is. Let's copy it down. I'm going to do it just copying and pasting with the keyboard this time. Control-C, down arrow, holding Shift, down arrow, down arrow, down arrow, Control-V. And then I'll double click on one just to see if it does what we want. Looks like it's doing what we want. Gonna underline down here, underline. The line is underneath. Summing it up and then summing it up. So there we have it. So this one obviously is a little bit higher in terms of the future cash flow because we're choosing the internal rate of return generally higher than our cost of capital. If it were not, we wouldn't have picked up the project, right? And this one would typically be the one that I would think would be used more often, given the fact that it's more conservative of a system, saying that I'm just going to assume we can reinvest it at our cost of capital.